Alright, so today we're going to be talking about covalent bonding and compounds. So there are two types of chemical bonds which are ionic covalent bonds. And ionic bonds form ionic compounds. Just kind of review of what we kind of went through already. Now, covalent bonds form covalent compounds, also known as molecular compounds. So whenever you hear molecular, I'm talking about covalent. Whenever you hear covalent, it's talking about molecular. Like those two words are pretty much interchangeable. Now, these chemical bonds are a chemical compound composed of two or more nonmetals. So there's a lot of nonmetals in there. Similar to ionic bonds, molecular compounds have chemical formulas, which is the composition of the compound structure. We call these chemical compounds for molecular compounds molecular formulas. When investigating what ionic compounds look like, there was no visible bonds formed. Remember, there was a donation of valence electrons. We moved those valence electrons to another, and then those two elements, those two atoms, became ions with charges. Well, in covalent bonds and covalent compounds, there is a share in valence electrons. Thus, a molecular compound will have visible bonds connecting the atoms this time, and you'll be able to see those when you start drawing these structures. So molecular compounds can be shown through the use of Lewis dot structures. So for ionic was the electron dot notation. Now for covalent compounds, it's Lewis dot structures. And here are the steps for drawing Lewis dot structures. Step number one is you're going to find the total number of valence electrons in the compound. You just look on the periodic table. We reviewed this last chapter. And remember, total is the sum. Now note, if there's a charge, so if this compound has like a -3 or a +1 charge, you're going to add or subtract what the charge tells you to the total. Remember, if it's positive, it's losing, so you're subtracting those. And if it's negative, you're going to be gaining those, so that's adding those. Two is you're going to arrange the atoms where there is one in the center and others around the center. Note the element that only has one in the compound is the center atom. So if we have CO3, there's only one sulfur, there's three oxygens, so your sulfur is your center atom, and then your oxygens will be the one that's surrounding that sulfur. Three is you're going to make the bonds between atoms. They're pretty much just lines that's connecting the center atom to the outer atoms. Now these bonds are called single bonds, and they're covalent bonds in which one pair of electrons is shared between two atoms. So each bond is two valence electrons worth. Okay, so when you see one bond, it's two valence electrons. Number four is you're going to subtract the number of electrons used to make bonds to the total amount of valence electrons. So you'll do how many bonds there are, and one of them equals 2, so the total, you subtract that to your total valence electrons you calculate in step 1. Then 5 is you're going to start making atoms happy. Now each atom should fall into something called an octet rule, and that octet rule is when all atoms have 8 valence electrons around it. It has nothing to do with like what the periodic table tells us initially, but once everything's bonded together into a compound, there's a total of 8 valence electrons around it, including bonds. But hydrogen wants 2, so all of them except hydrogen wants 2. You're going to start making surrounding atoms happy first, then the center. So you'll start making the outer ones happy, then start the center. Make sure the outer ones are full, like the box that you saw when we learned about ionic compounds, and then you do the center. You're going to add lone pairs, electron pairs, around each atom with the remainder number of electrons that you get from step 4. You may need to make double, so that's 2 bonds, which equals 4 valence electrons, or triple bonds, which is 3 bonds equals 6 valence electrons, depending on if you run out of your remaining valence electrons from step 4, you might need to start moving things around to make each atom happy. And you'll move a lone pair, so you'll remove electron pair to become a new bond. And again, you'll see these in the examples. Okay, so let's go ahead and practice doing the Lewis dot structures for these compounds. So the first compound we're going to be doing is OH2, okay? So remember, our first step for Lewis dot structures is we need to calculate the total number of valence electrons. So let's go ahead and do that. So we have oxygen. If you look on the periodic table, oxygen has 6 valence electrons, and there's 1 oxygen in this compound, so we'll multiply the 6 valence electrons by 1. Then looking at our second element is fluorine. Looking on the periodic table, fluorine has 7 valence electrons, and there are 2 of them in the compound, so we'll multiply that by 2. So plugging that in the calculator, just doing math in your head, 6 times 1 is 6, 7 times 2 is 14, so 6 plus 14 is it's 20. So we have 20 valence electrons to make this structure. Second step is determine which one's our center atom and place that in the center. If we have 1 oxygen and 2 fluorines, the one that always has 1 to it is oxygen. So the oxygen is always going to be our center atom for this compound. And then we're going to use our surrounding atoms to put around the oxygen. Now remember, when we were doing the ionic compounds electron dot notation, we talked about that boxing. So we have to put something here, 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 or here. If we have 2 fluorines, we've got to put 2 fluorines. So I want to put them on the side here. Now I could also put them on the top or the bottom or whatnot, but we're just going to do that. And our next is we're going to connect our center atom to our surroundings by just doing a line. Connect it. Now these lines are your bonds, and remember each shared bond is 2 valence electrons worth. So if we have 2 bonds and each of them are 2 electrons, so we got 2 and then 2 here, the total valence electrons we used is 4. 2, 4. So we will take that 4 valence electrons we used, subtract it to our total, and we get 16 valence electrons left to play with. And that's when we'll go ahead and start doing our electron pairs, our lone pairs. You always remember, each element wants to have 8 valence electrons total around it. Does nothing to do with the valence electrons, it's different. This needs to be 8. It's called the octet rule, okay? So we'll start making our outer surrounding elements happy first. 1, 2, 3, 4, 5, 6. I can't put any more dots anywhere around this because this side's already taken by the bond. So we'll move on to our next fluorine. 7, 8, 9, 10, 11, 12. I have 16, I just used 12, so I still have more to go, so I'll move on to our center one. So we have 12, 13, 14, 15, 16. Those are all my dots. I used up all those 16 with those dots. So let's go ahead and see if they're happy. So remember, these bonds are shared. So this is fluorine's valence electrons area. Fluorine has 2, 4, 6, and then that bond is 8. Since fluorine has 8, fluorine is happy. Let's look at this fluorine here. Remember, we have to check. So we have 2, 4, 6, and then the bond is 8. So fluorine is happy. And then let's go ahead and check our oxygen in the middle. Like, remember, these bonds are sharing. So it's not only sharing with the fluorine, but sharing with the oxygen. So oxygen is 2, 4, 6, 8. It is happy. So your final answer for this is that. Now when you go ahead and submit these pictures for your homework, I need to see all of your work. So all of this, I need to see all of this. At least your total number of valence electrons and then your final compound. If you want to show this happy, just to make sure they're happy, feel free to do that as well, but I need majority of this work on your homework. Go ahead and do another example. This time we have SO3 as our compound. Again, remember our first step is we got to figure out how many valence electrons this compound has, so that total, so that sum. So sulfur, on the periodic table, it tells me that sulfur has 6 valence electrons. And there's 1 sulfur in the compound, so we'll multiply that by 1. Remember, we have to take the total. Our next is oxygen. Look on the periodic table. Oxygen has 6 valence electrons. And there's 3 of them in the compound, so we'll multiply that number by 3. Plugging this into the calculator, you get 6 times 1 is 6. 6 times 3 is 18. 18 plus 6 is 24 valence electrons we are going to need to use to make this Lewis dot structure. Next step, figure out which one's our center atom. We have 1 sulfur, 3 oxygens. Remember, the center atom is the element that's only one of them in the compound. There's only one of them in the compound. Since there's only 1 sulfur in this compound, sulfur is going to be our center atom. Okay. And then next is we're going to use our surrounding atoms, which is the leftover atoms, so in this case oxygen, around this sulfur. And also don't forget that box. I could have also put it up here if I wanted to or whatnot, but this is just how I want to arrange it. But if you want to arrange it differently, go for it. Just make sure you remember that box. The next is connect your surrounding atoms to your center atom. Now, these, you cannot connect your surrounding atoms to each other. So these bonds will not exist. It's only from your surrounding to center, surrounding to center, surrounding to center, okay? And then we go ahead and subtract how many valence electrons we use to make those bonds. Remember, 1 bond is 2 valence electrons. We use 3 at bonds, so we have 2, 4, 6. We use a total of 6 valence electrons to make those bonds. So we'll subtract that from our total. So we have 18 valence electrons to use. Okay. So let's go ahead and start making our electron pairs with those remaining 18. Remember, we're going to make sure our surroundings are filled before we go to our center. So 1, 2, 3, 4, 5, 6, filled, move on. 7, 8, 9, 10, 11, 12, filled, move on. 13, 14, 15, 16, 17, 18. All right, we got no more dots because we used up those 18 valence electrons. So let's go ahead and check if each atom is happy. Let's look at this oxygen. Remember, to make it happy is that they want 8, the octet rule. So we got 2, 4, 6, and an 8 with that bond. So this oxygen's happy. Let's move on to this one. We got 2, 4, 6, and an 8 from that bond, so that one's happy. We're good at that one. Then we got this one here. 2, 4, 6, 8 with that bond. So we are good with that one. And then let's go ahead and check our sulfur. We got 2 from the bond, 4 from the bond, 6 from the bond. So we have 6 valence electrons that's being shared, that's being around that sulfur. Is that sulfur happy? No, because remember the octet rule, sulfur wants 6. So this is a very, very sad sulfur right now. Well, we have no more valence electrons to place.
We can't place any bonds, we got nothing. But we can move an electron pair to become a bond. So I can use any of these electron pairs. Let's go ahead and just use this one here. I can take this electron pair and move it here to become a bond. And remember, those are double bonds. So I just made a double bond between oxygen and sulfur. So that means that these valence electrons are gone. They don't exist here. It's in that bond. So let's go see if oxygen is still happy. 2, 4, 6, 8. Happy because it's 2 bonds now, so it's 4, 6, 8. So it's happy. And let's check to see if sulfur is happy now. We got 2, 4, 6, 8. Hey, sulfur's happy now. So all the elements are happy. All the atoms are happy in this Lewis dot structure. So our final structure is that. Okay, so let's go ahead and do another example. Now this time we have SO2 as our compound, so let's go ahead and take the Lewis dot structure for that compound. First step always is to figure out how many valence electrons are present in this compound. So we gotta take the total. So looking at the periodic table, sulfur has 6 valence electrons, and there are 1 of them in the compound, so we'll multiply that 6 by 1. Looking on the periodic table, oxygen has 6 valence electrons. And there are 2 of them in the compound, so we'll multiply that number by 2. And calculating that total, we got 6 times 1 is 6. 6 times 2 is 12, so 12 plus 6 is 18. Our next step is to figure out which one is our center atom. Remember, center atom is the atom that has only 1 of them in the compound. There's only 1 of them in the compound. So looking at CO2, there's only 1 sulfur. So sulfur is going to be our center atom. And then the leftover atoms in the compound is going to be our surrounding. There's 2 oxygens. Let's go ahead and put them in the surrounding. Again, you can place them top, bottom, anywhere, but this is just how I want to place it. And then you're going to connect your surrounding atoms to your center atom. And those are your bonds. Now, we made 2 bonds. Remember, 1 bond equals 2 valence electrons. So we got 2 valence electrons, 2 valence electrons. So we got 2, 4. We use a total of 4 valence electrons. So we'll subtract that from our total valence electrons we have. And that means we have 14 valence electrons left over to do our electron pairs. So we got to start doing our electron pairs. Remember, we fill out our outermost first, and then we'll go to their center. So fill out the surrounding atoms, and then if we have anything left over, start filling out the center one. 1, 2, 3, 4, 5, 6. Filled, so we'll move on. We still got more valence electrons. 7, 8, 9, 10, 11, 12. Filled. We have 2 more, so we'll go ahead and put them on the sulfur. So let's go ahead and check if each of these atoms in the structure is happy. Let's go ahead and look at this oxygen here. We got 2, 4, 6, and 8 from the bond. Oxygen's happy. Moving on here, we got a C, 2, 4, 6, 8 from the bond. This is happy. And then let's go ahead and look at our sulfur. So we got 2, 4 from the bond, 6 from the bond, so we have 6 total valence electrons. Is that 8? No, so sulfur is very sad right now. So remember the last problem. We can make double or triple bonds by moving electron pairs to make an atom happy. So let's just go ahead and move one of those bonds, one of those electron pairs to make a bond. You can choose any of these, but I'm going to choose this one. You move it, and that formed a bond. So now these valence electrons do not exist anymore. So let's go and check to see if this oxygen's still happy. We got 2, 4, 6 from this bond, 7 from 8 from this bond, so it still has 8, so it's still happy. Let's go ahead and check our sulfur. We got 2, 4, 6, and our 8 from our new bond. Now sulfur has 8, so now sulfur is happy. So your final structure, final answer for this is that. Okay, so let's go ahead and do another one. Now this time we have P2 as our compound. So our first step is to figure out how many total valence electrons there are. So looking at the periodic table, phosphorus P has 5 valence electrons. And there are 2 of them in the compound, so we'll multiply it 5 by 2. And that's all we have in the compound, so 5 times 2 is 10 valence electrons. Now our next step is to figure out which one's our center atom. Remember, our center atom is the atom that there's only one of them in that compound, but there's only one atom and there's 2 of them. So which one's the center atom? Phosphorus can't be the center atom, so there is no center atom. All you're going to be doing if you get a compound that just has 2 elements, just P2, or it could be O2, N2, Cl2, any of those, you'll just put the phosphoruses next to each other, like that. And then we bond them together with one bond. Now, to make that one bond, we use 2 valence electrons because remember, 1 bond equals 2. So we use 2, so we'll subtract that from our total. So we have 8 valence electrons left over to use. So let's go ahead and start doing those dots. Remember, fill out one atom at a time. 1, 2, 3, 4, 5, 6 filled. We still got more. 7, 8. So let's go ahead and check and to see if they're happy. So let's go ahead and check this phosphorus here. Got 2, 4, 6, the bond 8. 8 octet rule is good, so this is happy. So let's go ahead and check our other one. We got 2 and then 4 from the bond. That's nowhere near 8. So this phosphorus is very, very sad. It's crying. So it needs 4 more valence electrons to get to 8. 4 more shared valence electrons. So remember, the last 2 problems we did was we moved electron pairs to become more bonds. So let's go ahead and do that. Since we want this phosphorus to be happy, we can mess with this phosphorus. Let's go ahead and move this bond over here. So its pair's gone. Let's go ahead and check to see if this is happy now. 2, 4, 6. Not happy yet. So we got to do it again. Let's go ahead and see if this is happy now. 2, 4, 6, 8. This phosphorus is finally happy. And let's double check to make sure this phosphorus is still happy. We got 2, 4, 6, 8. This phosphorus is still happy. So your final structure for this is this with that triple bond. Okay, so let's go ahead and do another one. I know we're doing a lot of them, but we need to kind of see different ones. Our next one is a little bit different because now we have CO3 2-. This time, this molecule has a charge. And I'll talk about what that means in a minute. So your first step to do the Lewis dot structures, total number of valence electrons. Carbon, look at on the periodic table. Carbon has not 5, my bad, has 4 valence electrons. And there's 1 of them in the compound, so we'll go ahead and multiply that by 1. Next we have oxygen. Looking on the periodic table, oxygen has 6 valence electrons. And there's 3 of them in the compound, so we'll multiply that by 3. And this is where that charge comes into play, because remember, negative, they're gaining electrons. Positive, they're losing electrons. This one gained 2 valence electrons because it's a -2 charge. Negative gained, so it gained. It's a -2, so it gained 2 electrons, 2 valence electrons. So we got to add 2 more valence electrons because of that charge to our total. So doing that math, 4 times 1 is 4. 6 times 3 is 18. 18 plus 4 is 22. Plus 2 more, we get 24. So our next step is to figure out which one is our center atom. So the center atom, remember, is the atom that we only have one of them in the compound. We have 1 carbon, 3 oxygens, so carbon is our center. And then we put our surrounding atoms around the center. And we got 3 oxygens. And we connect those with bonds. So remember, 1 bond equals 2 valence electrons. So we use 2, 4, 6 total valence electrons to make those bonds. So we'll subtract that from our total. So we have 18 valence electrons to use up. So let's go ahead and start making our electron pairs. Remember, we make our surroundings full first before we go in the center. So we got 1, 2, 3, 4, 5, 6, still have more. 7, 8, 9, 10, 11, 12, still have more. 13, 14, 15, 16, 17, 18. I got no more. Let's go ahead and check if they are happy. So we got this oxygen here. 2, 4, 6, 8. Happy. Got this oxygen here. 2, 4, 6, 8. Happy. Then we got this one here. 2, 4, 6, 8. Happy. Then let's check our center. 2, 4, 6. Uh-oh, it's not 8. This carbon is not happy. Remember, if something's not happy, we got to figure out which electron pair we need to move to make another bond, a double bond or a triple bond, depending on how many we need to make it happy. So you can choose any one of these, but I'm going to go ahead and choose this one. So this is going to move to become a double bond, and these are gone. So let's go ahead and check to see if this carbon is happy now. 2, 4, 6, 8. Hey, this carbon's happy. And let's check if this oxygen is still happy. 2, 4, 6, 8, still happy. So your final compound is structure, as I mean. Is that. But remember when we did kind of the electron dot notations for ionic compounds, if there's a charge, we need brackets. We still need brackets since it says a charge. So we'll put a bracket around the whole compound of a 2-. Okay, so let's do one last example before I let you guys practice some on your own. Now this time we got PO4 3-. First step, and also notice before we do our first step, is that this one also has a charge. So we gotta remember that when we make our total number of valence electrons. First step, total number of valence electrons. Phosphorus, looking on the periodic table, phosphorus has 5 valence electrons. And there's 1 of them in the compound. Looking on the periodic table, oxygen has 6 valence electrons. And there's 4 of them in the compound. Then we've got to look at that charge. That charge is -3. Remember, negative is gaining valence electrons, so we're adding valence electrons. If it's a -3, this compound gained 3 valence electrons, so we've got to go ahead and add 3 valence electrons to our total. So doing that math, 5 times 1 is 5. 6 times 4 is 24. 24 times 5 is 29, plus 3 is 32. That's a lot of valence electrons. So now our next step is to figure out which one is our center atom. So PO4, the atom that has one of them is phosphorus. So phosphorus is in our center. And we put our oxygens, our surrounding atoms, around the phosphorus. And we'll go ahead and bond those together. Now we used 4 bonds. Remember, 1 bond equals 2 valence electrons. So we used up 2, 4, 6, 8 valence electrons. So we go ahead and subtract that from our total. So we got a leftover of 26 valence electrons. So let's go ahead and use those valence electrons to start making our dots. So we got 1, 2, 3, 4, 5, 6 filled, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You know what? No, it's not 26. Sorry, I can't do math. It is 24, actually. Sorry. I can't do mental math. There we go. It's 24. So we just used up 24. So we used 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24. That's all our valence electrons we used up. Let's go ahead and check to see if each of these are happy. I'm just going to circle all of the oxygens. So we'll check those first. For this oxygen, we got 2, 4, 6, 8. Happy. 2, 4, 6, 8. We're happy. 2, 4, 6, 8. We're happy. 2, 4, 6, 8. We are happy. And let's go ahead and check our center atom, which is phosphorus. 2, 4, 6, 8. Phosphorus is happy. So this whole compound is happy. So let's go ahead. So our final structure is but again, there's a charge of -3, so we got to do brackets to make it -3. And that's your final structure.
All right, so on your own, you're going to draw the Lewis dot structure for the following covalent compounds. So try this one. And here's your answer. Try this one. 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 Here's your answer. Then try this one. And there's your answer. All right, that's it.